Hello. In this video, we are going to discuss a question based on time and work. The question is, a contractor had employed 1,000 laborers for a flyover construction task. He did not allow any woman to work without her husband. Also, at least half the men working came with their wives. He paid 5 rupees per day to each man, 4 rupees per day to each woman, and 1 rupee per day to each child. So he gave out 200 rupees every evening. The question is, how many men, women, and children were working with the contractor? So, like the only information that we have is in total there were 100 laborers. Second information is that their payment information 5 rupees to each man, 4 rupees to each woman, and 1 rupee to each child. One more information is there that the number of women is at least half that of men, right? So, let us write down the equations first. So let us assume the number of men to be M, that of women to be W, and that of children to be C. Now the first equation is that the total of all the three must be equal to 100, as they were total of 100 laborers, and the second information is regarding their payment. So 5, so suppose M men's are working and each man gets 5 rupees, so the total payment to men is 5M. Similarly, each woman gets 4 rupees and the number of women are W, so the total payment to women is 4W, and that to children will be C only, right? 1 rupee to each child, and this total must be equal to 200. Now these are the two equations with a one more information is there, that is the number of women is at least, see this information here, at least half of the men working came with their wife. So the number of women is at least M by 2. Half of the men came with their wife, at least half, and the maximum value of W can be M, both equals, right? Y equal to M. The maximum number of men that can come with their wives is 100%. Like all the men can come up with their wives. But the minimum number of men that came up with their wife is M by 2, half the men. Fine. So the value of W can vary between M by 2 to M. Now these are the two equations. Now since we have one more information regarding M and W, so let us try to eliminate this variable C. So from equation first, we can say that the value of C comes out to be 100 minus M minus W. Now simply substituting this value in this equation, 5M plus 4W plus 100 minus M minus W, and this must be equal to 200. On further solving this equation, we'll get 4M plus 3W equal to 100. Now we have one equation and we have two variables now. So we'll try to use this condition. Now the extreme, let us take the extreme cases. What extreme cases I'm talking about? Now extreme cases are the minimum number of women is equal to M by 2. This is the minimum number of women possible, and the maximum number of women possible is M equal to that of men. Right. So I am taking two extreme cases. Now substitute this value in this particular equation. Let me mark this as equation 3. So 4M plus each woman is equal to half men. So this will become 1.5 men. This must be equal to 100, or 5.5 M must be equal to 100. Or from here M comes out to be how much? 100 divided by 5.5. That would be somewhere around 18.18. Now obviously the number of men cannot be in fraction, but then this is the extreme value of number of men. Number of men 18.18 से ज़्यादा नहीं हो सकते हैं. Now similarly let us check for the second equation as well, when the number of women is equals number of men. So 4 men plus 3 men equals 100. Now since W is equal to M, so let us replace W by M. So here from here we get 7M equal to 100, or M from here comes out to be 14.28. Now this is the minimum number of men's possible, and this is the maximum number of men's possible. So although we don't have any idea about the exact number of men's, but we can say that the value of M will definitely lie between 15. It can be either 15 because it cannot be in fractions. So it can be either 15 or 16 or 17 or 18. So we have these four options. We have got a range for minimum and maximum number of males possible, right? Now let us try to check this equation. When we substitute m as 15 in this particular equation, so this will become 60 plus 3w is equal to 100, which is not possible because w from here will come out in points or decimal, you can say. So this solution is not possible. Let us cancel this out. If I substitute value of m as 16, so this will become 64 plus 3w is equal to 100, and from here w will be equal to 36 divided by 3, that is 12. Now this is a feasible solution. Fine, so this value is quite possible. Let us try to substitute 17 as well. So this will make 68 plus 3w is equal to 100. Again the value of w will come out in fraction, so again not possible. Substituting 18 will get 72 plus 3w equal to 100. And for the same reason, we can ignore this solution as well. The value of w from here will come out in fraction. So there was only one possible value of m for which we are getting an integral value of w. So from here we can say that the number of men were 16, that of women were 12, fine, and the remaining must be children. So children must be 72. Now the total become 100, that is fine. Now let us check for the second equation as well. The total wages to men would be 16 into 5, 80 rupees. That to women will be 4 into 12 is 48 rupees, and 72 to 72 children. The total is 200. So we can say that this is the perfect solution to this question. The number of men is 16, that of women is 12, and that of children is 72. So this was a good question from time and work. I hope this question is clear to you. Thank you.